Now, let's move on to one of the main ideas of this section, the net change theorem. The net change theorem tells us the new value of a changing quantity equals the initial value plus the integral of the rate of change. So in symbols, we write f of b equals f of a plus the definite integral from a to b of f prime of x dx. And another way to write the same idea is the definite integral from a to b of f prime of x dx equals f of b minus f of a. Let's talk about what this really means. F prime of x is the rate of change. The integral adds up all those small changes, and that gives us the total change, or what we call the net change. So the integral is basically telling us how much did the quantity change overall. Let's connect this to some key terms. Rate of change is the derivative, like velocity or growth rate. Net change is the total change over the interval. Initial value is the starting value, in this case, f of a. Final value is the ending value, in this case, f of b. The integral represents net change, or total accumulation over the interval. There are two important things to remember. Net change includes positive and negative values. So if the quantity goes up and then down, the integral keeps track of both. Second, the integral counts for direction automatically. So you don't need to adjust signs manually. The integral does that for you. Now, let's look at an important application of this idea. This comes up a lot when we talk about motion. Net displacement is the overall change in position. Total distance is the total amount traveled, no matter the direction. To find the net displacement, we take the integral of the velocity. And to find the total distance, we take the integral of the absolute value of the velocity. So what is the difference? For net displacement, positive and negative velocities can cancel out. For total distance, we take the absolute value, so everything counts as positive. In simple terms, net displacement tells us where you ended up. Total distance tells us how far you traveled. So in this section, the key idea is the integral represents total change. And depending on the situation, that can mean the net change or total accumulation.